Welcome back everyone to another LeetCode problem solving video. Today we're doing day 27. We are almost a month into these videos and I think we have an interesting problem today. We can choose between either 2 pointers or stack. I say let's go with stack because we have 2 problems here. The next one's threesome. I'm sure if you heard of it, it's a fun problem, but honestly, if we check stack, we also have 2 problems. This problem right here, evaluate reverse Polish notation, it's a more interesting problem actually, and I say let's go with that one. Cool, let's go ahead and read the problem. Evaluate reverse Polish notation, okay? The first thing, obviously, you have to know what reverse Polish notation is. This is a very particular problem, and we're gonna go ahead and check that on here in Wikipedia, but I save you some time. Reverse Polish notation is basically a type of notation that was used back in the days, as you can see here, 70s and 80s, by HP to do different type of calculations in a calculator. So basically the way it would work is that you have, as you can see here, 2 operands, right? An operand, first operand, second operand, and then you have the operator. And you would input 3, 4 plus, and it would perform the addition of these numbers. But as you can see here, it's reversed because we're used to see, and I'm sure, okay, I'll explain that later, but here, for instance, you know, we're used to see this type of notation where to add 3 and 4, we would do 3 plus 4, right? We have the operator here, and we have different operand on each side of the operator, right? That's what we're used to in most systems, right? That's what's normal for us in math. But the Polish notation says basically we're gonna grab the operands and first and then the operator, okay? That's pretty much all you need to know. If you want to go ahead and read this, go ahead and do it, but technically, you know, you have to process 2 different kind of things, operators and operands, okay? That's what we need to know before. The problem says you're given an array of strings, tokens, that represents an arithmetic expression or arithmetic expression. Evaluate the expression, return an integer, thank you, that represents the value of the expression, okay? So basically, as the calculator, technically, we're gonna have different operators, so plus, minus, times, and division as tokens, okay? You can see they are surrounded by the single quote here, which represents a token, right? Or a string, a character. And then we have different operands that could be, you know, integers, numbers, whole numbers, negative numbers, or maybe floating point numbers, right? It's an integer here, but we're gonna be dividing, so at some point we're gonna have to deal with floating point numbers here. But anyways, division between 2 integers always truncates towards 0, okay? So technically, you know, we don't have to worry about the decimal part, okay? So there will be no division by 0, so that's an HK we don't have to worry about. And then the input represents a valid arithmetic expression in a reverse Polish notation, okay? So we don't have to decompose the string and verify order. The order would be provided by the problem itself, okay? That's another edge case. So just technically, you know, things that would make the problem a little clear or, you know, easier to navigate. Then the answer and all the intermediate calculations can be represented in a 32-bit integer. That's another good thing. We're not going to have overflow or underflow of numbers here. So another thing we don't have to check. Obviously in Python, we won't worry too much about that. Pretty much all operations we're going to be performing, they can fit on a 32-bit integer. The accuracy of that would also, there won't be any problem with that because we're also truncating towards 0. So at some point we're going to convert into, you know, if we have a floating point, we're going to be converting it to an integer. So there's some of that, but a couple examples, okay? The first clue here in this problem is the word tokens, okay? As we mentioned before in previous videos, every time we have to process, we've solved problems actually where we have to process tokens. Belly parentheses is a great example. It's actually the best problem to start. We said that in the previous video, I believe. But when we have to process tokens, it's important to know that there is a master data structure that it's used often for this kind of things, and it's a stack. Okay, Stack is going to be very powerful to process tokens because of LIFO property, right? Last element that came into the stack is the first element to leave the stack, okay? So this is very good when we have to parse things. And tokens, in this case, are going to need to be parsed because technically, you know, we're going to have expressions. Notice how also, let's notice how the, next time, let's notice how these integers, numbers are coming in characters, right? They are surrounded by quotes, right? So these things, we're gonna have to convert these integers at some point, okay? Or the strings into integers. So yeah, basically, you know, when you have to process any token or characters separately, maintain order, backtrack something, the stack is going to be great because the property of LIFO, last element that came in, it's the first one to pop out. It's going to be extremely helpful for that. It maintains the order, okay? So saying that, you know, let's go ahead and put a stack over here and let's continue to solve the problems. I'm just going to represent that as a bucket, you know, stack could be a bucket. Everything you lay on the bottom stacks all the way to the top. Anyways, let's go ahead and check the examples here. We have 2, 1, plus, and 3, and times, okay? A equals to 9, it gives you the explanation here. 2 plus 1 times 3 equals 9, okay? So technically we are, you know, solving for the parentheses first. That's 3 times 3, 9, okay? Cool. Same thing here. We have 3 numbers and then 2 operators. So the idea in this problem is to maintain integers and operators order, okay? Because let's say, let's pick this second example right here, right? Let's pick this one. If we have 4 right here, right? We see 4 and okay, I'm going back to kind of explain a little how we're seeing 4. We're going to iterate over tokens, okay? But I think that's well known by now that we have to iterate over these data structures to manipulate them. I think that that's something that's, you know, from the get-go in every problem pretty much here. Let's go ahead and read the constraints before I jump into here. Okay, tokens, you know, the length of the array is going to be all the way to 10 to the 4. And again, you know, 32-bit integer for pretty much all operations here. We're going to be looking for at least a linear time complexity. Why? Well, because, you know, that's a decent input array. That's a decent input right there. So for that, you know, linear time, at least, if we can do something better, even better. But the fact that we have to iterate over all of them to, you know, abstract or subtract the integers and characters tells me that we're gonna at least be dealing with linear time. And then the integer is either an operator or an integer in this range, okay? Minus 200 up to 200. We're gonna be dealing with negative numbers, okay? So that's something we have to think about at the time of solving the problem. But anyways, let's go ahead and check these next time. Let's check these input right here as we started. So we see 4, we're iterating over these array here, and we see 4, then we see 13, okay, and we're just simply adding it to a stack we're going to create. We're ready to say why we're using a stack. So we have 4 and 13 and then 5, okay? We see 3 numbers in a row, and then we see our first operator, okay? It's the division operator, okay? So what do we do? So a good option we could do here, because we don't want to stack the division operator here, because then we would have to go, let's say, you know, all the way down to here and call let's say this operand and this operand to use this operator, okay? We're going all the way down to the second element here. So instead of doing that, okay, and remember, we're trying to maintain complexity low in our case, because it can get to a point where we are going to be stacking things on top here, and we're going to have to traverse our stack too, okay? We don't want to do that because we're already traversing this list. We don't want to get into a crazy complexity here. So what do we do? Okay, a good solution for this could be keeping the operator separated from the actual characters, okay? Now, notice how we see another operator here, and let's say if we want to keep this operator a variable, you know, that's a variable for, you know, keeping division there, holding division. You know, it could be a pointer towards that element or whatever, but in this case, let's say it's a variable. So the variable division, okay? And then we see the variable, sorry, the operator plus. Okay, let's call that v2, another variable, okay? And this is an example of what we're not going to be doing, but I want to explain why. Well, because now we have two operators that are technically, look what we have a stack technically, because we have two variables that are holding two operators that we're going to be using. Remember, these things are strings, okay, or characters. So, you know, we can technically assign it to a variable or a pointer in any case. But we have to go to the stack and grab operand 1 and operand 2, okay? So that way we could technically say, you know, give me the division of these two numbers, and then that result, we could probably stack it down here, right? And remove the top element, okay? We're trying to use our stack to perform that operation. That way we don't have to keep track of so many numbers, okay? But then we have to perform plus, then we have to perform addition. We have to add to the result of this two. So why don't we just create a stack for operators too? Instead of holding those variables and keeping track of which variable came first, in this case, let's go ahead and create another stack, okay? Remember, we're keeping time complexity to a minimum, but the fact that we don't have to worry about space in this case, we're not gonna be doing anything crazy, but two stacks, technically, one occupy a lot of space, okay? So let's keep a stack for operators, for operands in this case, and let's keep a stack for operators, okay? So that's what we're gonna do. Let's say we see division here. We have these three numbers we saw here first. Then we have division here. What we're gonna do is call division in these two numbers, okay? What we said before, and then we're gonna divide, let's say 13 divided by 5. That's gonna be a floating point number, okay? And that's good that it's going to happen, because that way we could prepare for what's coming. So that's gonna be 2.6, I believe, or some 5, yeah, 2.6, okay? So 2.6 is going to be the result of this division right here, and that's what we're seeing right here. Now, remember, the problem says the division between two integers always truncates towards 0, okay? So technically, what we're gonna be doing here, instead of storing up here 2.6, we're going to truncate towards 0, which is, you know, we're gonna go not necessarily floor, because floors don't apply once we're past 2.5 obviously, but in this case, truncating towards 0 would be simply converting this value into an integer. So what we're gonna do, and let me not make this too messy here so I cannot go back, okay? So 2.6, I'm gonna do this. We could technically say, okay, so store 2.6 right here, or 2, okay? We're gonna truncate that into a integer, and we're going to store that here. So we're gonna have 2 here, and we can get rid of this element. We can just pop it to the top of the stack. Constant time operation, we don't have to worry about that. We can't even think about it. Delete it, done. That's the result for that first operand. Maybe next time, okay? Thank you. So what do we see? What do we have? We have 2 and 4. 2 is the result of us dividing the two operands that were here, okay? So now we have 2 and 4, and we see, what do we see down here? Let me scroll down. We're in example 2. We see the plus sign, okay? So the plus sign comes and gets added here. We do the same thing. Now we take the plus sign and operate these two values, okay? So what do we have? 2 plus 4 equals 6. These numbers are getting kind of crazy here, but it's kind of like art. So 6 in this case, we can do the same thing. We're gonna pop this element from here, and we're not necessarily popping it, we're just converting it, okay? And even though this integer is a whole integer, we're going to keep it as an integer. We're going to cast it as an integer, because we want to make sure that in the case that it's not, which was down here, we can operate on floating points truncated to 0. So this is going to be 6. We can pop again the top of the stack right here, and look what we have. We have a final number in our stack that's equal to 6. Look at the output here, and that's how we're going to do it. Technically, let me delete that so I can explain it. we're going to create 2 stacks, okay? One stack is going to be for operand and another one is going to be for operators, okay? We're going to apply the operator we have here. Let's say we have a plus into operand number 2 and operand number 1, okay? And these are our numbers. We're going to, let's say this is our case, we have 3. We're going to substitute or, say that this result is 3 and we can pop that element from the top and this is going to be our result, okay? Right here. And that's how we're going to solve that problem. So if we are ready, let's go ahead and jump into the code and see how we do it. There's a couple ways to do it. I'm going to choose the long route. There's probably a way shorter than the one I'm going to show you, but remember we're using Python. There's going to be a case here where probably the switch operator would be very ideal. Now Python doesn't have the switch operator, at least on, default Python 3. See the libraries automatically. Anyways, Python doesn't come with, out of the box, doesn't come with a switch operator. I'm not aware right now if that's the case, but for that, we're just going to be using a couple of statements. So let's first go ahead and create our number stack. Okay, so let's go ahead and do it. We're going to create a stack called nums, and that's going to be equal to a list in Python, right? So this is what's going to hold our stack. Okay, next thing we need to do is probably iterate over the tokens. So we're going to say for every token in tokens. Okay, first we need to check a couple things. What do we have? Do we have a number or do we have an operator? What are we dealing with? Do we have a multiplication sign or we have a 9? Okay, that's the first thing we're going to do. There's a very cool method in Python. It's called isDigit that we could use on strings or characters to check for that. But also remember, we're going to be dealing with negative numbers. Okay, so on a string, on a negative number, we have a minus signs. Now this is technically size 2, okay? That string has the minus operator and the 11 operand, okay? So that's size 2. How do we know that we, besides having a digit, also have a negative number, okay? Checking the size. That's why the character, or the string in this case, larger than a character, it's going to be useful here. So let's go ahead and do that. We're gonna say if the length of that token is greater than 1, meaning that we have another element there, probably a minus sign, or we're gonna say the token dot is digit, okay? Nope, digit, like this. We are going to append it to the num array, to the stack up here. So if the token is larger than 1 or is a digit, okay, we're gonna append it to nums stack. And let me explain that, okay? Again, we can have a positive number 2, that's a digit, but we could also have a negative number, which is size 2. So that's what we're checking for this condition right here. Is it a negative number or is it a positive number, okay? So if that's the case, then we're gonna say num append, and we want to make sure we're appending an integer. We don't want to keep the character or the string in this case, okay? So we're gonna cast it, calling the integer with the token, just like that. Perfect. Now, if it's not a number, negative or positive number, then we have to check for the operators, okay? And this is where I think the Swift operator in Python would be ideal, right? Because here we have to say, and I'm not gonna give you complaints about the language, I think Python is great for what it is. So here we're gonna say else, and then we have to check for all operands, okay? I wish there would be a shorter way to do this, the switch operator kind of, but we're looking for, a set number of elements, okay? These are all constant time operations. The only time we are iterating over the whole array or the tokens is right here. These are simple checks, okay? We're either checking if it's a plus, a minus, a times, or a division, okay? We're looking for that particular character, okay? So first thing we're gonna say is if that token is equal to a plus sign, then we're gonna perform sum in the last 2 elements of the stack, as I showed previously. So we're gonna say nums at index -2, right? Because we want the first operand and the second operand. Remember, we're in a stack. The first operand technically sits on the bottom part, right? or, you know, previously to the number on top. So we're going to say -2. And since we know it's a plus sign, our particular case here, we're going to say plus equal nums at position -1. Great. So we have a sum here. We determined this is a sum. So we go ahead and add it. Here, this is pretty much very convenient here. This is very, very convenient in Python. The fact that we're grabbing, you know, the element sitting on that position, you know, we can iterate backwards, calling the negative numbers. We can grab that number at -2, that number at -1, and basically plus equal, you know, that's our result. Great. Then from here, what do we do? Well, now we have to check for the other cases. So we're going to say elif token. Now we have to check if it's a minus, right? Or a subtraction. We're going to do this and say same thing. Nums, we just changed the operator. Nums at -2 minus equal nums at -1. Great. And that's pretty much the subtraction part. We're going to do here the same thing. Elif token equals. So now we're looking for multiplication, right? So let me see here. There we go. Nope. There we go. So if that's the case, we are going to say the same thing. Nums at -2. And we're going to say times equal nums at -1. Great. And so far, so good. We have, you know, the operand when it's plus, minus, or multiplication. So, and we're technically, again, doing the same operation. The only thing that changes is the operator, okay? The operation that's happening between these two numbers, either a sum, subtraction, or multiplication. Cool. We have a last case, and it's division. Division gets a little tricky because, again, we have negative numbers, we have floating point numbers, and we have to make sure that as we have here, it's truncated towards 0. Okay, great. So here, all we're missing is division, as we said. So we're going to say else, and we are going to first, let's go ahead and convert the number into an integer. We don't care if it's a floating point or whatever. The first thing is we need to make sure when it goes to the stack, it's an integer. Okay, so we're going to say num. We're going to grab the same number at position -2. It's going to be equal to integer. Here we're going to convert whatever number we get into a floating point. We want to ensure, again, that even if we don't have a floating point, let's say we have number 2, we want to make sure we're dealing with 2.0 instead. So that way when we apply division, we don't care if it's a whole number, if it's a decimal number or a negative number. Okay, we're departing from the same NAT base of number. Okay, so let's do it like this, float. And then that same number, nums at position -2, and we're going to divide that by nums at position -1. Great, and that's pretty much it. You know, we are making sure that this number right here, which is, you know, the second operand sitting on underneath the top of the stack, it's an integer when it goes back to the data structure, when it goes back to the stack. But at the time of doing the operation, we want to make sure we have either, if we have an integer, a floating point, or a negative number, we are departing from the fact that the number is a floating point because we're using this type of operator. Okay, so there's that. And now here we can remove that number from the top. Remember when we were done with the operation on the second level, we removed the number from the top because we don't need it anymore. So we could say nums.pop. Great, so we remove that number, and then now we're pretty much done. Everything that's left in the stack is that final result, okay? And this is pretty much how a RPN, reverse Polish notation, would operate on a calculator. We technically made a little part of the code that HP calculators were using. So we're going to return our function here. And what are we going to return? Well, the only thing that's left in the stack really is num at position 0. Okay, we removed everything right here that was left. See how here we always operated on that second element, operated on that second element, on that second element, and then we remove what's sitting on top, the last thing that's sitting on top. So that's it. Pretty much, I think that should solve our problem. I don't think I have any syntax issues here. That's a cool thing about Python, not a lot of checking. So we should meter run. Let's run. Let's not be greedy here. Great, we passed the first 3 test cases. Let's go ahead and submit. Thanks for my coin there. Oops, accepted. How do I mean, oh, here we go. Wowzers, okay, 100%, nice. Great, so very efficient, I guess. Let's check that time complexity, guys, because, you know, that's important for us. From time, okay, here we go. Where am I clicking? Anyways, perfect. Yeah, linear time. That's what we needed. Okay, so there's that. We don't really need to worry about this now. That's kind of crazy. We almost hit 20 megabytes there on 2 stacks. But anyways, yeah, that's pretty cool. That's how we solve our problem of today. Guys, smash that like button and subscribe if you find anything valuable here. Let me know in the comments. Let me know what you think. How are you doing in your journey? Do you have a YouTube channel? Are you following? Are you keeping track of your projects? What are you doing? Let's stay in touch. Also, I have a Discord now. If you guys want to join me, I'm going to leave it in the description. So yeah, I'll see you guys there. And thanks so much for your time. Hope you keep grinding on LitCode. Let's go.